So this is 4.2a in college algebra. The name of the section is exponential functions and graphs. So one of the things that's going to be important when we're dealing with exponential functions, which looks like this, a number to the x power. This here is our variable, and that's one thing that's important. And another thing that's important is this number a. Whatever number is represented by a has to be a positive number, and it cannot be 1. So that's called an exponential function of base a. Now, notice that when we did other stuff, we had things like this, like that, where we did not know the base, and we knew what the exponent was. Well, in an exponential function, the variable is in the exponent. So we might have a base with a variable of x in the exponent position, and that's going to be an exponential function, and that's where we're going to get into logarithms. So let's say that we have example 1, y equals f of x, okay, those are interchangeable, and that equals 2 to the x power. If we wanted to use a table, and we had x, and we had our y value, or our f of x value, we could put a 0 in for x, and that would give us a 1 for our y, because it would be 2 to the first power. Put a 1 in there, or 2 to the 0 power equals 1. 2 to the first power equals 2. 2 to the second power equals 4. And we just kind of keep going on and on and on there. We could put, in fact, a negative 1 here, and we get 2 to the negative 1 power equals 1/2. And we can just keep going there, negative 2, and anyway, we keep going, and we get a 1/4 here for our negative 2. And we get a graph. Alright, so let's go ahead and graph this. This is 0, 1. Let me get a different, darker color here. Let's go with red. 0, 1. And then 1, 2. And then 2, 4. And then negative 1, 1/2. And negative 2, 1/4. So we end up with a graph that looks, well, not like that. Like that. This will never cross the x-axis. It comes close, but it doesn't touch or cross it, even though my drawing doesn't show that necessarily. And that's what an exponential function looks like. So notice what happens when somebody says it increases exponentially. It means it increases really, really fast once you get to a certain point. Then it just goes up like that. Alright, so as x increases, as this x goes from left to right, the y value increases without bound, which means this will go up and up and up forever and ever. Amen. So that as x approaches infinity, y approaches infinity. As x approaches negative infinity, as it goes this way, y approaches, well, what happens? As x gets closer and closer to infinity, negative infinity, what happens to the y value? We get smaller and smaller and smaller, so it approaches 0. Never gets there, but it approaches 0. And then we have, as the y-axis, or the x-axis ends up being my y equals 0 is my horizontal asymptote. So as x inputs decrease, the curve gets closer and closer to the asymptote or the x-axis, but it does not cross it. So let's look at example 2. Y equals f of x equals 1/2 to the x power. And they're just asking you to graph that. So again, you're just making a list of x's and y's here. And we we put in a number like 0, and obviously that gives us a y value of 1. We put in 1 for this, and 1/2 to the first power gives us 1/2, and 2 gives us 1/4. Let's go and get some negative numbers, and -1 gives us a 2, -2 gives us a 4, and a -3 gives us an 8. Alright, so let's bring our graph down here, and let's make it a little bit bigger so we can get some of these fractions in here. 0, 1, 1, 1/2, 2, 1/4, -1, 2, -2, 4, and -3 is way up. So we end up with that again. And again, it does not cross the x-axis. Gets close. As x increases, the function values decrease. So as x gets bigger, the y value gets closer to 0. As the x value decreases, the y gets larger, or it increases without bound. Okay, so bottom of page 363, let's look at these two graphs. Let's look and see what happens here. This is f of x equals 0.7 to the x power, and this is 0.4, this is 0.25. So notice this number in front, this base number, 0.7, gives me a graph that looks like this. As the base number goes from 0.7 to 0.4 to 0.25, to where it gets smaller, the base gets smaller, what happens to the graph? It makes a sharper turn as it gets smaller. Now let's look at this one here. This one is 4, and look how sharp of a turn this is. And this is 2.5, it becomes less sharp, and 1.8 even gets to be less sharp. Now what's the difference here? These numbers are all bigger than 1, and these numbers are all smaller than 1. So causes things to happen completely different. Alright, so let's look at page 364. Alright, so top of page 364, connecting the concepts. Let's look and see what's going on here. Let's compare some characteristics of exponential functions, keeping in mind that the definition of an exponential function, f of x equals a to the x power, requires a to be positive and different from 1. So a, the number we put in there, has to be positive and larger than 1, and the x value is the variable. Alright, so that's what this says. F of x equals a to the x power, where a has to be a number bigger than 0, and it cannot be 1. Alright, one of the things about the graph is it's continuous. It continues on, there's no break, there's no sharp pointy things. It's 1 to 1, which means when you do the horizontal line test, it works. The domain, the x values, are -infinity to +infinity. The range, the y value, starts at 0 and goes up into infinity. It will not cross this x-axis. Increasing if a is greater than 1. If a is greater than 1, that means from left to right it will go up, like this one here, and like this one here. See, this one has a 2 and this one has a 4. So if the base value, this a right here, this number, is bigger than 1, it's going to increase from left to right. If it's between 0 and 1, so like these here, 1/4 and 1/2, they're smaller than 1 but greater than 0, they're going to decrease from left to right. They're going to go down from left to right. The horizontal asymptote will be the x-axis, and the y-intercept will always be the point 0, 1. Okay, so those are some important properties as we're doing these. Now, what we're going to do here in this next example is we're going to do something different to the general function. So if we have f of x equals, well, let's take that one, 4 to the x power. All of this is going to be true. What changes is, what if I do this? it's going to have the same shape, but this is going to make some difference here. So I'm going to explain what happens here on these examples on example 3. And I think what I may end up doing, because this one's going to take a little bit to get through this particular example, I'm going to start the next video since I'm at 10:20.